Okay, so let's go ahead and talk about this problem here, which says factor 10m to the power of 6 negative 7 m cubed n squared negative 12 n to the power of 4. Now, this looks like a very involved problem, right? And the reason why it looks involved is because it's not very comparable to a quadratic expression. And let me remind you, a quadratic expression looks something like this. Ax squared plus bx plus c, right? This is how a quadratic expression looks like. Now, this equation here is not comparable to this. Now, we know how to factor an expression like this, right? If we have an expression in the form ax squared plus bx plus c, we know how to factor that very easily. It's very convenient, right? So why don't we use the techniques that we use to factor something like this or an expression like this? But before we do that, I want to give another example in which we can easily use this technique to factor that out, and then we're going to use that example as our blueprint to work on this problem. Okay, so let's go ahead and do that here. So let me put that example here in orange. So I'm going to use this example here, which is 5h squared minus 14h minus 3, right? So what's the first step when we want to factor something like this? The first step, of course, is to identify the a, the b, and the c, right? The a here is 5, the b is negative 14, and c is negative 3. So we want to identify those. And the first, and then we want to make sure we want to multiply a with c, right? In this case, a times c is going to be equals to 5 times negative 3, right? And that'll be equals to negative 15. Now, we want to look for factors of negative 15 such that when we add those two factors, we get negative 14, right? So let's look for some factors here, 1 and 15. And I think that's it, right? Because if I stick 1 times, let me put a negative sign here, 1 times negative 15 gives us negative 15. But when we add 1 negative 15, we get negative 14, right? So we're there. So when we multiply these two numbers, we get a times c. When we add them, we get the b value, which is negative 14. Okay, perfect. So now let's go ahead and replace the b value with these two factors that we found here. So we have 5h squared minus 15h plus 1h minus 3. And again, notice that we have not changed anything here, right? Because negative 15h plus 1h, that's the same thing as negative 14h. So we're not changing anything here. It's just a different way of writing what we initially had. And this is going to be useful for us when factoring this. Okay. So here's the deal. What I want to do now is I want to focus on the first two terms here and kind of expand them, right? So what I'm going to do when I say expand them, I want to write them more explicitly, right? So the number 5 can be written as 5 times 1. And I'm doing this in an attempt to see what's common between these two terms, right? So the 5h squared can be written as 5 times 1 times h, right? 5h squared is 5 times 1 times h, right? And then 15 can be written as 5 times 3. And then we have negative 15h, right? So that will be negative 5 times 3h. And then we have plus 1h, that's just plus h minus 3. Let me put my equals to sign here. Now, what I want to do is I want to start my factorization process, right? So let's see what's common between my first two green terms. What's common between them is this 5 here. I have a 5 here, I have a 5 here. I have an h here, I also have an h here. So what's common between these two terms is 5h, 5h, that's what's common. So let me go ahead and write that 5h outside the bracket. And inside my bracket, I'm going to write h. because that's what's missing here, right? Notice that 5h, this is outside the bracket. So what's missing here is just 1h. So I just write that inside my bracket. 1h is just h, right? So I write that inside my bracket. And then what's left here? So 5h is outside the bracket. So what's remaining here is just -3. So I write that -3 here inside my bracket. The next step is to just copy and paste whatever I have inside my bracket here. Just copy and paste this. Copy and paste this here. That's it. And then what we do is we want to find out what number do we need to multiply, or what number or a variable number plus a variable that we need to multiply with h to get h. In this case, that's just +1. We just need to multiply +1 with h to get h, and +1 with -3 to get -3. That's it. Now we can write this more compactly, and our factorization will then be done, right? So more compactly, you can combine the 5h with the +1 here, and that's going to give me 5h plus 1. And then in my second bracket, I'm going to have h minus 3. And this is my factorization done for this question here. Perfect. Now, what I want to do is I want to use this technique that I used for this quadratic expression, and try to work on this expression here. It looks challenging, but it's not all that challenging, right? So let's work on this together here. Okay, so 10, notice that the number m to the power of 6, this can be written, if we know our exponent rules, the number m to the power of 6 can be written as m cubed to the power of 3, right? Because according to exponent rules, this expands to m to the power of 3 times 2, which is m to the power of 6, right? Therefore, we can do that. And then everything else remains the same. So I'm just rewriting this in a way that I think is going to be convenient for us in this particular question, right? Okay, now what I'm going to do is I want to make a decision here. What I want to do is I want to relabel my variables. And in this case, I want to give m cubed a name. I want to say m cubed is just equals to x. Okay, let's see what happens if I do that. If I say m cubed is just equals to x, I'm going to get 10 x squared minus 7 x n squared minus 12 n to the power of 4. Well, this looks promising, right? Because this is at least a little bit comparable to what we have here. So this expression here is a bit comparable to whatever we have here, right? Let me kind of write this in a different way, and that way is going to help us to identify our a, b, and c values, right? So this will be 10x squared, and I'm just gonna, it doesn't matter in what order I multiply, right? So I'm just gonna write this as 7n squared x minus 12 n to the power of 4. So in this step, what I've done is, instead of writing it as negative 7x to the power x times n squared, I've written this as negative 7n squared x. So I've just kind of, changed the order of multiplication, which we can do. There's no problem with that. Okay. Now what I want to do is, so as I said, in the example that I mentioned here, in this example, initially we identified the A, the B, and the C. In this case, the A was whatever number we had beside h squared, right? And that was 5. The B was whatever number we had beside h, which was -14, and C was the constant term. Now in this case, what I want to do is I want to identify my A, B, and C values. So let's go ahead and do that. Let me put this in a different color here, because this is going to be important when we're writing our final solution. Okay, so let me go ahead and do that. So let me identify A, which is 10, because that's the number beside x squared. Let me identify my B, and that should be the number that we have beside x, and in this case, that is 7n squared. And C is just going to be the entire -12 n to the power of 4, right? So those are my A, B, and C values. Okay, now what was the next step? What was the next step in this example here? The next step was to multiply a with c. In this case, our a is 10 and our c is negative 12 n to the power of 4. But what I'm going to do here is I'm going to ignore this n to the power of 4. I'm just going to multiply these constant terms. 10, I'm going to multiply that with negative 12. And let's see what we get. So if I do that, I'm going to get, let me just do that here in the margin. So if I do 10 times negative 12, I should get negative 120. Okay, what is the next step? The next step was we're supposed to look for factors of negative 120, right? And negative 120 has many factors. So let me identify some of those here. Well, it has, the factors are 1, 120, right? And again, I'm going to ignore this negative sign for now. 1, 120. Let me just not ignore that. Negative 1, 120, right? Those are the factors. And then we have 2 and then 2 and 40. Sorry, 2 and 60. Then we have 3 and 40. And then we have 4 and 30. And then, of course, we have 5 and 24, right? And then 6 and 20. And then we have 8 and negative 15. 8 and negative 15. That's my last factor that I have here. And there's more factors as well, but I think in this case, 8 and negative 15 is going to work for us. And let me just stick a negative sign here with each of these because we have negative 120, right? So either of these could be negative, right? So negative, 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 right? Okay. Now notice that 8 and negative 15 work here because if I do 8 times negative 15, I get negative 120. But if I do 8 plus 15, I get negative 7. I get my b value, right? So notice when we look for these factors, we're looking for the factor to satisfy a certain condition. And what is that condition? When you multiply those factors together, we should get a times c. In this case, a times c is 10 times negative 12. I'm ignoring the n to the power of 4. When we add those factors, we should get the b value. In this case, again, ignoring the n square that we have here, the b value is negative 7. So in this case, these factors here work. 8 and negative 15 work because 8 negative 15 gives us negative 7, which is without the n square, that's the b value. And 8 times negative 15, that gives us negative 120, right? Which is a times c. Again, ignoring the n to the power of 4. Okay, so this works here. Let's go ahead and rewrite our b value here using our newfound factors. So we have 10x squared negative 15 n squared, and be careful because you want to make sure that whatever we have beside with the b value here, whatever variables we have, in this case the variables are n squared x. Technically we're not treating n squared as a variable here, we're treating it as a constant, but nevertheless. So in this case it's going to be negative 15 n squared x, right? And then the second term is going to be, third term here is going to be positive 8 n squared x negative 12 n to the power of 4, right? And notice again, as we did in this example, we are not changing anything here, right? Moving from this point, from this step to this step, we're not changing anything. Negative 15 n squared x plus 8 n squared x is the same thing as negative 7 n squared x, right? So it's just a different way of writing the same thing, but this is going to be incredibly useful for us when we start factorizing this, right? Okay, let's move on. So what was the next step? The next step was to look at our first two terms and write them more explicitly, right? Write those first two terms in a more explicit manner. Let's do that. So we have 10, let me use my green color here, this one. So this equals to, and then let me use this green color for this, which is going to be 10, sorry, I want to write this more explicitly, right? So the factors of 10 are 5 and 2. And then I have times x squared can be written as x times x. Then I have negative 15 can be written as negative 5 times 3. And then I have n squared, which can be written as n times n. And then I have x. And let me write everything else in blue. Plus 8n squared x minus 12n to the power of 4. Okay, now let's start grouping these terms together. This is going to be equals to, what's common between the first two terms? What's common is I have 5 here. Let me use my pointer. I have 5 here. I have 5 here. So 5 is common. Then I have x here, and I also have x here. So 5x goes outside the bracket, and everything else goes inside the bracket. Let's do that. So 5x goes outside the bracket, and everything else. What's missing here? After I remove 5x from here, we're left with 2x. This 2x goes inside the bracket. After we remove 5x from here, what's left is negative 3 times n, which is just negative 3n squared. So that goes inside the bracket. So we're left with 2x here and negative 3n squared here, right? Okay, now the next step is just copy and paste this directly here. Whatever we have inside the bracket, copy and paste that directly here, and this gives us, this is what we have, right? Now, what do I multiply? What do I multiply with 2x to get 8n squared x? Now, here's an easier way to see this. 8n squared x can be written as 2 times 4 times n times x, right? We already have 2x inside the bracket. So remove this 2 and this x. What's missing is 4n squared, right? 4 times n, which is just 4n squared. So we write that outside the bracket. So this is just going to be 4n squared. What's next? We write this more compactly. So this is going to give us 5x plus 4n squared times 2x minus 3n squared. There's one last step that we have to be careful here. Notice that initially we said that m cubed is going to be equals to x. So this x here, we should relabel this now that we're done factoring, we should relabel this x as m cubed. Let's go ahead and do that as our final step here. So we have 5 m cubed plus 4 n squared times 2 m cubed minus 3n squared. And this should be our final answer.